Welcome back to Math Dogs. If you're new to the channel, please comment, like, and subscribe. If you have any questions, please comment down below. Today's topic is rational expressions and equations, and we have 6 examples for you worked out step by step. Remember, we believe math is better with your dog, so call your pups. Let's get started. Problem number 57 is the domain of a rational function. It says find the domain of y equals 5 over 3x plus 2. So in a rational function, the denominator cannot equal 0. So we have to find the value that makes 3x plus 2 equal to 0, and then x cannot equal that value. So this is a simple equation. I'll subtract 2 from both sides. 2 minus 2 is 0. 0 plus 3x is 3x, and 0 minus 2 is negative 2. Divide both sides by 3. 3 divided by 3 is 1x. X would equal negative 2/3. So the domain would be all real numbers, except x cannot be equal to negative 2/3, because that would make the denominator equal to 0. Problem number 58 is simplifying rational expressions. It says x squared minus 36 over x minus 6. So since we can only cancel factors or divide factors to 1, we have to see if we can factor the numerator or the denominator. Now the numerator is x squared minus 36. That's a difference of squares factoring pattern. And so x squared minus 36 will break into x minus 6 times x plus 6. The denominator is already factored. However, I like to put it in parentheses because sometimes it's clearer to see which factors would be able to divide out. So any factor on the top and any factor on the bottom that are the same will divide to 1. So x minus 6 divided by x minus 6 is 1, or as some people say, it cancels out. 1 times x plus 6 is your answer, x plus 6. Problem number 59 is multiplying rational expressions. It says x squared plus x minus 12 over 2x times 8x plus 20 over 2x squared minus x minus 15. So there's a lot of different skills that go into this problem, but we're going to see if we can look at it piece by piece and block it out. So I have to look at each of the 4 sections of this problem and see if that expression is factorable. I like to block out what's about to happen, so I'm going to have fraction bar times fraction bar. And then I'm going to factor or look at each piece, and I'm going to write where that piece belongs in the spot that I blocked it out. So x squared plus x minus 12. Since there's a hidden 1 right here, I need 2 factors of 12 that subtract to give me 1. That would be x plus 4 times x minus 3. Now I'm going to look at that denominator, 2x. 2x is already in factored form, so all I'm going to do is express it in this line and wait to get to the third line. 8x plus 20 has a greatest common factor of 4, so I will factor out a 4 and be left with 2x plus 5. And in the last denominator, or the last piece, I have 2x squared minus x minus 15. So I need factors of 2, which are 1 and 2, factors of 15, which are 1 and 15, or 3 and 5, and I need to make sure that my outside-inside subtracts to x. So that would be 2x times x. I would need the 3 to get a 6x on the outside, and a 5 to get the 5x on the inside, 2x plus 5 times x minus 3. Now I need to see if there's any factor on top that could cancel with any factor on the bottom. It doesn't matter which side it's on. So I see I have an x minus 3 on the top and an x minus 3 on the bottom. Those would divide out to 1, or as some people say, cancel out. I also have a 2x plus 5 over 2x plus 5. Those would also divide out to 1, or again, as some people say, cancel out. I also have a 2 and a 4. 2 can divide into 2 one time. 2 can divide into 4 twice. Now that I've reduced everything, all I have to do is multiply across the top and multiply across the bottom. So x plus 4 times 2 will give me 2 times x plus 4. In the denominator, I just have 1 times x, which would be x. And so my answer is 2 times x plus 4 over x. Problem number 60 is complex fractions. It says 5 over x squared minus 2x over 3x over x minus 2. So a complex fraction is just a fraction within a fraction. It always has a main fraction bar, which is right here, and you'll see there's a fraction on the top of that main fraction bar and a fraction on the bottom of that main fraction bar. The easiest way to deal with a complex fraction and simplify it is to multiply the top and the bottom by the least common denominator. So I'm going to find what the least common denominator of x squared minus 2x and x minus 2 is. So I need to factor. X squared minus 2x is x times x minus 2. X minus 2 is already in factored form. Now to find my least common denominator, I need to take the lowest exponential power of every factor that I see. So first I see an x. I'm going to include that over itself. Then I have an x minus 2 to the first. I also have another x minus 2 to the first, so I'm going to include that. X minus 2 to the first, x minus 2 to the first. So anything over itself is just 1. Since I'm multiplying by 1, I'm not changing the value of the complex fraction. I'm going to put each of those over 1 so it's easier to see how we'll multiply on the top and the bottom of the main fraction bar. So x times x minus 2, x will divide out x, and x minus 2 will divide out x minus 2. That leaves me with 1 times 5, which is 5 in the numerator of the main fraction bar. In the denominator, I'll have x minus 2 divided out by x minus 2. That leaves me with x times 3x, which is 3x squared. And so the complex fraction simplified is 5 over 3x squared. Problem number 61 is adding rational expressions. It says 6 over x minus 5 plus 8 over x plus 5. So when I'm adding and subtracting fractions, even if they're algebraic fractions, I need a common denominator. So, as before, I like to put these in parentheses to see exactly what my factors are. I also like to block out the problem, so I have fraction bar plus fraction bar. So I need to take the lowest power of every factor that I have. So I have an x minus 5 and an x plus 5. I will need both of those in my least common denominator. So I'm going to write x minus 5, x plus 5 in the left fraction, and x minus 5 times x plus 5 in the right fraction. I had a 6 in the numerator to begin with in the left fraction, and I had an 8 to begin with in the numerator of the right fraction. So now I just need to figure out what form of 1 I need to multiply by. So you'll see I have 6 over x minus 5. That still exists in the fraction. What I've multiplied by in the bottom is x plus 5. So I need to multiply that on the top as well. So now I have the original fraction, here it is, multiplied by a form of 1. So I'm not changing the value. In the second fraction, I had an 8 over x plus 5. And you can see the 8 over x plus 5 here. What's new is the x minus 5. And so I'm going to have to multiply the numerator as well, x minus 5, to have x minus 5 over x minus 5, which is just 1. Again, anything times 1 does not change the value. Since my denominators are now common, I can add. So I'm going to write down my common denominator, x minus 5 times x plus 5. In the numerator, I have 6 times x plus 5 plus 8 times x minus 5. And so now all I have to do is simplify. Like previous problems, I have two distributive properties, 6 times x plus 5 and 8 times x minus 5. So I'm going to simplify those. That would give me 6x plus 30, and the multiplication because the parentheses closed, plus 8x minus 40, and all of this will still be over the denominator that was common, x minus 5 times x plus 5. Now I'm going to simplify this numerator. 6x and 8x are like terms. They would add to 14x, and 30 minus 40 is negative 10. I'm going to put that back over the common denominator of x minus 5 times x plus 5. And so my answer would be 14x minus 10 over x minus 5 times x plus 5. Problem number 62 is solving rational equations. It says x minus 3 over x plus 3 plus 4 over x minus 3 equals x minus 9 over x minus 3. So there's a lot of different skills in this problem. We're going to take it piece by piece, step by step. The first thing I'm going to do is put all of my binomials in parentheses so I can see better as what factors they are. Just like any equation with fractions in it, we want to multiply both sides by the least common denominator in order to eliminate the denominator or the fractions and just get back to a regular type of equation. So this time I'm going to have to multiply both sides. There's two terms on the left side and the single term on the right side. I'm going to look at my denominators. Remember, I need the lowest power of every factor. So I have x plus 3 to the first. I'm going to need to include that on both sides. And I have an x minus 3 to the first. I'm going to need to include that on both sides. Since I'm multiplying both sides of the equation by the same value, I'm not changing the structure of the equation. So now I'm going to multiply both terms on the left side and the single term on the right side. And this is how we do it. X plus 3 will divide out with x plus 3, leaving you with x minus 3 times x minus 3. And I'm just going to express that in the next line, x minus 3 times x minus 3. You'll notice I eliminated the denominator, which was my goal. For the second piece, I have x minus 3 divided out with x minus 3, and so now I have x plus 3 times 4. So I'm just going to express that, 4 times x plus 3. On the right side of the fraction, x minus 3 will divide out with x minus 3, leaving me with x plus 3 times x minus 9. And I'm just going to express that, x plus 3 times x minus 9. So step 1 is finished. I've cleared out the denominators. Now I have a lot of simplifying to do. I have a FOIL, a distributive property, and then on the right side, another FOIL. So I'm going to have to use past skills. So x minus 3 times x minus 3 will give me x squared minus 3x minus another 3x plus 9 plus 4 times x is 4x, 4 times 3 is 12. On the right side of my equation, I have another FOIL. X times x is x squared minus 9x plus 3x minus 27. So I have a lot of combining like terms to do. I have x squared minus 3x would be minus 6x plus 4x would be minus 2x. And 9 plus 12 is 21. On the right side of the equation, I have x squared, negative 9x and positive 3x is negative 6x minus 27. And now I can begin to solve. I'm going to subtract x squared from both sides. X squared minus x squared is 0. 0 minus 2x plus 21 is negative 2x plus 21. And that equals x squared minus x squared is 0. 0 minus 6x minus 27 is negative 6x minus 27. And now at this point, we're back to a structure that we should be familiar with from previous problems. I'm going to add 6x to both sides to keep my variable positive. Negative 2x plus 6x is 4x plus 21 equals negative 6x plus 6x is 0 minus 27 is negative 27. And finally, we're down to a two-step. Subtract 21, divide by 4. So I'll subtract 21 on both sides. 21 minus 21 is 0. 0 plus 4x is 4x. And negative 27 minus 21 is negative 48. When I divide both sides by 4, 4 divided by 4 is 1x. And negative 48 divided by 4 is negative 12. So my answer is x equals negative 12. So that's it. 6 examples of rational expressions and equations. Keep working hard. Don't ever give up. We know you can do it if you put in the time and effort. And as we say at Math Dogs, you got this.